Here is our sorted array: 2, 5, 8, 12, 16, 23, 38, 56. Given a target, we want the index where it lives. But if the target is missing, we instead want the index where it would slot in to keep the array sorted. For a target of 10, 10 is not here, and it belongs right before 12 at index 3. This is lower bound wearing a different hat. Because the array is sorted, we have the window each step, looking for the first position whose value reaches the target. If the target is actually there, that position is exactly where it sits. If the target is missing, that same position is precisely the gap it should be inserted into, pushing the larger values one step right. One search answers both cases. Low starts at 0 and high at the length of the array. While the window is open, we look at the middle. If the middle value is below the target, the spot is further right, so we move low past the middle. Otherwise, we pull high down to the middle. When they meet, low is the insert position, whether the target was found or not. Let's build search insert position live, one block at a time. Low starts at 0 and high at the length of the array, one past the last index. While the window is open, we look at the middle position. If the middle value is smaller than the target, the spot lies to the right, so move low up. Otherwise, shrink high to the middle, and when the markers meet, low is the answer. Now, let's test it and hit run. There we go. 16 is already present at index 4, 10 is missing, and it belongs at index 3, right before 12. And 60 is larger than everything, so it would go at index 8 at the very end. The shape is the lower bound shape. Set low to 0 and high to n. While low is below high, take the middle. If the middle value is under the target, move low up, otherwise move high down. When they meet, low is where the target sits or where it would be inserted. It is a single binary search, so every step halves the window and we finish in order log n time. We keep only 2 markers in the middle, so the space is order 1. 3 things to remember. First, start high at the array length so a target bigger than everything correctly lands at the end. Second, recognize that this is lower bound in disguise, so the same code handles found and not found together. And third, resist the urge to nudge the answer at the end. Low is already the exact slot.